Welcome back. This video is part 2 of the series. I'll be going through the last 2 pages of the 4 pages of trig that was sent to me by a student who asked for help in one of my other videos. If you haven't seen part 1, that's okay, though these questions I find are a little bit more difficult than the one I did in part 1. So if you find that these questions are overwhelmingly difficult, then maybe it'll be a good idea for you to check out part 1 first. Let's get into it. Question 1. The value of cos 1 degree times cos 2 degrees times cos 3 degrees, etc., etc., until you times all the way to cos 100 degrees is what value? 2/3, 1/3, negative 1/3, or 0? Again, I don't have the answer sheets for these questions, so if you think I'm doing the question wrong or if I've made a mistake, just drop a comment below and we'll get through this together. The way I went about doing this question was, first of all, I sketched the graph, the cos graph, and up to 100 degrees it would look like this. So that's at 100 degrees. This would be 90 degrees. Cos 90 degrees should be 0, but let's just double check that. Cos 90 equals 0. Anything multiplied by 0 is going to be 0, no matter how many values there are multiplying it. And since cos 90 degrees is 0, every other value here multiplied by it will just be 0. So 1, I think, is D. Let's go to 2. The value of sine 10 degrees plus sine 20 degrees plus sine 30 degrees plus all the way up to plus sine is 360 degrees is what? Once you've drawn the graph, it'll be incredibly evident that if you add all the values together, it's going to be 0, because if you imagine all the values, so this might be 0.1, this might be 0.2, all the way up to here, which is positive 1. And then you have all of these values, which would be negative 0.1, and that will be negative 0.2, all the way down to negative 1. All these values added with all these values in the negative form is going to be 0. Just hypothetically speaking, if all of these values added up to, let's say, positive 3, and all of these values added up to negative 3, let's say, it's going to be the same. Like, it's just one's positive, one's negative. If you add them together, you're going to get 0. So it might not be 3, but whatever it is, added with the negative of the same value, you're going to get 0. I'm pretty happy with that one. Let's go to 3. The value of cos 15 degrees is what? It seems like they want the exact value of cos 15 degrees. Cos 15 degrees is one of those values that doesn't have... Ooh, look at that. That's interesting. Wow. I didn't even know my calculator can do that. Yeah, this doesn't look like any of the options we have available. So let's see what we can do. Since exact values only occur with angles of 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, etc., in those sort of vein, the question is, how do we get 15 degrees, right, from these values? At first I thought, if I look at my trig identities, at first I thought the half angle formulas would be good, because then I can do cos half of 30 degrees and I just use the positive of this, because this is only positive or negative because if you look at the cos graph, there's positive values and then there's negative values. But cos 15 degrees is definitely in the positive range. So you would use this and you'd use the positive version of that, and then you have the cos 30 degrees. And cos 30 degrees is, what is cos 30 degrees? Root 3 on 2. So that has an exact value of root 3 on 2, and you simplify that. But when you simplify that, you're not going to get any of the values that's in the question. So I had to figure out what else I can do. And another way to get 15 degrees is to do cos of 60 degrees minus 45 degrees. And we can use this one here. And that will become cos 60 degrees cos 45 degrees. And then it'll be a plus sine 60 degrees sine 45 degrees. When we do that, cos 60 is half. Times cos 45 degrees. If you don't know how to get these exact values, you can always use the triangles that it stems from. So we start off with a equilateral triangle, which is all 60 degrees. All the sides are 2. And if we draw a perpendicular line coming down from here, that angle will now be 30 degrees. I should just redraw it like that. That is 30 degrees. That is still 2. That is 1 now because it's split in half. And this side would be root 3 because 2 squared minus 1 squared is 3, and it's the square root of 3. This will still be 60 degrees. The 45 degrees come from, where am I going to draw this? The 45 degrees come from an isosceles triangle, both of these being 45 degrees. This will be 1, that will be 1, this will be root 2. Square root of 1 squared plus 1 squared. So looking from this, cos 45 degrees would be adjacent over hypotenuse, which is 1 on root 2. Let me double check that. Cos of 45, yes, that's 1 on root 2. So that's the same. Plus sine 60 degrees would be opposite over hypotenuse, so root 3 on 2. Times sine 45 degrees opposite over hypotenuse, 1 on root 2. And that will equal to 1 on 2 root 2 plus root 3 on 2 root 2. And that's going to equal 1 plus root 3 all over 2 root 2. Let's see if we have found it. Yep, that's A. Root 3 plus 1 all over 2 root 2. And let's check just in case. Cos 15 degrees equals, let me swap color. So that is 0.96592582 dot dot dot. Now I'm gonna write 1 plus root 3 on 2 root 2. I think that's the same. 0.96592582. Yep. Alright, I'm happy with that. So I'm going to say question 3, the answer is A. Let's go to question 4. If cos theta minus alpha is 3/5 and sine alpha plus theta, or theta plus alpha, equals 12 over 13, then the value of cos 2 alpha may be what? This one took me a while to get, so let me get my notes. I looked at the trig identities at first, and I instantly saw that we have the trig of an angle plus or minus another angle, and we get these. And I thought I needed to expand this first using that, but that got me nowhere. And then eventually, after a lot of minutes went by of just trial and error of a lot of different methods, I came to realize that to get the angle 2 alpha, what I could do with these two angles is I have theta plus alpha as one of the angle. If I minus theta minus alpha, I will get 2 alpha. And that got me really excited because I needed a 2 alpha. Now, how do we get, what do we do with this? I also noticed that these values look like Pythagorean numbers, Pythagorean triangles. So I drew the triangles out. Didn't know whether it'll help or not, but I just drew it out and see where it'll lead me. So that angle is theta minus alpha, and I drew another one for theta plus alpha. Cos theta minus alpha is adjacent over hypotenuse, so that side must be 4, because 3, 4, and 5 are Pythagorean numbers. Sine of theta plus alpha is opposite over hypotenuse, so this side must be 5, because 5, 12, and 13 are also Pythagorean numbers. Then, where did I go from here? I wanted cos 2 alpha. To get cos 2 alpha, I needed to do this. Just bear with me here. Might be a bit long, but we have to stick through it. So this is equivalent to cos 2 alpha. Everyone agree? Yeah? Alright. Now I can use the trig identity for the difference of the two angles and expand it. So I've got cos x, that means cos theta minus alpha, times by cos y. Wait, what? No. There. That's better. That would have been a big mistake. Cos x times cos y, and then plus sine x times sine y. Okay. Then we just use these triangles to get the values. Cos theta plus alpha is adjacent over hypotenuse. That's 5 on 13, times by cos theta minus alpha, which is 3/5, plus sine theta plus alpha is 12 on 13, times by sine theta minus alpha is 4/5. That is going to give us 15 on 65 plus 48 on 65, and that is 63 on 65. Oops. Do we have 63 on 65? Yes, B. Woohoo! Question 5. Which of the following is true if pi is less than theta less than 3 pi on 2? These are radians. So that's 180 degrees, and 3 pi on 2 is 270 degrees. Now we just need to draw all these graphs. I'll start with sine. Between 180 to 270 degrees, it is not greater than 0. So A is not right. We can rule out A. B, cos graph and sec graph. Okay. Cos graph between 180 to 270, it is negative, so that looks good. Yes, the second graph. So between 180 to 270, it's all negative. Let's see what it says. Sec is positive. No, that is wrong. A and B are out. Let's move on to C. Cos graph is not positive, so that's out. So the only thing left is D, but let's double check. Cos graph is negative, yes. Cot goes like this. Oops, more like that. That's at 90. This is at 180 degrees. And then it goes again like that, and that's at 270 degrees. Therefore, between 180 and 270, it is positive, and that is correct. So cot theta is greater than 0, and cos theta is negative. I would say it's D. I would definitely want to check this, just in case. We just pick an angle that's between 180 and 270. Let's pick 200 degrees. Let's go cos 200 degrees. It's negative, good. Let's do cot of 200 degrees. So that's 1 over tan 200. Whoops. Tan 200 degrees is positive. Yes, I think it's D for number 5. Let's go to 6. The cosine of the angle swept by the minute hand of a clock in 20 minutes is what? This question is actually not that hard. So a clock hand in 20 minutes is 120 degrees because it's a third, basically, of a circle. Because that would be at 20 minutes, this will be 40 minutes, and then this will be back up to 60 minutes. So in 20 minutes, the angle swept by the minute hand is 120 degrees. The cos of 120 degrees is what? $120 degrees would be around here. It's 30 degrees away from 90 degrees, and it will be the same value but the opposite direction of 60 degrees. Okay, so if we know what cos 60 degrees is, then cos of 120 degrees would just be the negative of that. Cos 60 degrees is adjacent over hypotenuse, which is a half. Therefore, cos of 120 degrees will be negative a half. Right? D. Let's check it. Cos of a half is... oh my goodness, what happened? No, that's not right. Cos of 120 degrees is negative a half. There you go. So if you're allowed to use a calculator, you literally just put in cos of 120 degrees and you get negative a half. If you can't use a calculator, you have to draw it out, use your head a little bit, and see what the graph tells you. On to question 7. If sine theta is a half, where theta is, I believe that's in between 0 and 90 degrees, then cos and tan of the complementary of theta are respectively what? There is a lot to unpack here, but let's start with sine theta is a half. If theta is in between 0 and 90 degrees. Let's draw the graph again. At 90 degrees, where sine theta is a half, theta is going to be opposite over hypotenuse is a half. That would have to be 30 degrees. Let's check that. Sine 30 is a half. Therefore, theta is 30 degrees. It can't be anything else because it has to be between 0 and 90 degrees. Then the cosine and tangent of the complementary of theta respectively is what? Complementary angles means right angle. Therefore, cos of the complementary of this would be 90 minus 30 degrees, which is cos 60 degrees, which would be adjacent over hypotenuse a half. Tan of the complementary degrees would be tan 60 degrees, which would be opposite over adjacent. No, wrong way. Opposite over adjacent, root 3. Therefore, it is B, half and root 3. Let's double check that. Complementary angle, so cos 60 is half and tan 60 is root 3. Right? That was relatively short, shorter than I thought. The trick to this question is just understanding the question, I think. Being able to recognize that symbol and also what complementary angles mean. Other than that, it's pretty straightforward. Let's go to 8. If sine theta 1 plus sine theta 2 and sine theta 3 equals 3, then cos theta 1 plus cos theta 2 plus cos theta 3 is what? For these to add to 3, it has to be 1 plus 1 plus 1, because there's no other way for it to add to 3. I'll try to explain it as best I can. Because the maximum value that sine can be is 1. Anything less, you'll get, let's say, 0.99, right? You can't get 3 if you do 0.99 plus 1 plus 1, because that will just be 2.99 whatever. The only way to get a 3 is to get the maximum value, which is 1 for the first sine, plus 1 again, plus 1 again. Therefore, each of those angles must be either 90 degrees, negative 270 degrees, or 360 plus 90, 360 plus 90, so 450 degrees, etc. It has to be one of those angles. Then cos of these would be what? So let's just assume that all these angles are 90 degrees. Let's draw the cos graph. At 90 degrees, cos 90 is 0. That means it's going to be 0 plus 0 plus 0, which will equal 0. D. Alright, let's move on to question 9. Question 9, the minimum value of cos x is what? Let's start with cos x. Cos x can be in between positive 1 all the way to, let's just put y, to negative 1. Then cos of cos x would just means cos of anything from the value of positive 1 degree all the way to negative 1 degree. If we draw a graph, it's literally like the tiniest bit of the cos graph from negative 1 degree to positive 1 degree. So the minimum value are here. That's the minimum value. That's the lowest it gets, is when it's at negative 1 or it's when it's at positive 1. So the minimum value of cos x is going to be cos either 1 or either positive 1 or negative 1, because they're gonna have the same value, same y value, which will be the minimum value of this graph. So it'll be cos 1. Even if you chose cos negative 1, it's the same thing as cos 1, because if you look at your trig identities, cos of negative x is the same as cos x. So that's the same as cos 1 as well. So it all comes down to C, cos 1. Question 10. If sine x equals cos squared x, then cos squared x times 1 plus cos squared x is equal to what? Let's start with the first equation of sine x equals cos squared x. Cos squared x is 1 minus sine squared x. We have cos squared x outside of 1 plus cos squared x. Oh right, cos squared x equals sine x. Therefore I can say that that's sine x, and I can say 1 plus sine x. Here, I'll expand that to sine x plus sine squared x. Oh, right. I get it. Sine x is cos squared x. I'm going to set that back in. Plus sine squared x equals 1, because sine squared x plus cos squared x is 1. There you go. 10b, 1. Question 11. If sine alpha plus beta equals 1 and sine alpha minus beta is equal to half of, what is that? Alpha comma beta inclusive between 0 and 90 degrees. Okay, yep, got it. Then tan of alpha plus 2 beta times tan 2 alpha plus beta is equal to, oh my goodness. Let's unpack this little bit by little bit. We've got sine alpha plus beta equals 1, which means, and alpha and beta are in between 0 and 90 degrees, which means alpha plus beta has to be 90 degrees. Then we have sine alpha minus beta is a half, which means alpha minus beta has to be 30 degrees. We can actually find out what alpha and beta is. Let's go with alpha is equal to 30 degrees plus beta. I'll sub that into here, which means 30 degrees plus beta equals 90 degrees. 2 beta is 60 degrees, beta is 30 degrees. Then sub that into here, which means alpha is equal to 30 degrees plus 30 degrees, which is 60 degrees. Now that we have this, it's actually really easy now to do this, because it's just tan of 60 degrees plus 2 times 30 degrees times tan of 2 times 60 degrees plus 30 degrees, which equals tan 60 plus 60, so that's 120 degrees, times tan 120 plus 30, that's 150 degrees. That becomes tan 120 is minus root 3. Tan of 150 is negative 1 on root 3, which is just positive 1. So 11 is B, 1. Let me just double check that, just in case. Tan 120, tan 150, whoops, equals 1. Alright, that was good. Let's go to the last question. Last question, question 12. We have, if cos A is 3/4, then sine A on 2 times sine 5A on 2 is what? I'm going to start with sketching out a triangle. Cos A is adjacent over hypotenuse. So this side would be square root of 16 minus 9, which is 7, so square root of 7. What do we know? We know cos A is 3/4, oops, equals 3/4. Now we know sine A is going to be root 7 on 4. Then we can go to sine A on 2 times sine 5A on 2. And if we go to our trig properties, we can see sine x times sine y is equal to this. Let's use it. It equals to half outside of cos x minus y minus cos x plus y, equals half outside of, this would be cos negative 2a, and this is going to be cos 3a. Cos of negative 2a is the same as cos of positive 2a. We just did that in the previous question, so I'm just going to get rid of that negative sign. What else can we do? Cos 2a is one of these. Let's just choose one. So half outside of. Let's choose this one. 2 cos squared theta minus 1. That will give us 2 cos squared a minus 1 minus cos 3a. I'm just leaving 3a for now because I don't want to deal with it right now. We have half outside of 2 times cos a is 3/4 squared, which means 9 on 16, minus 1 minus cos 3a. We have half outside of 2 times 9 is 18 on 16 minus 1, which will be 16 on 16, which will be 2 on 16, which is 1 out of 8. I skipped a lot of steps there, it's just because I'm running out of room. But if you were doing this in an exam, please write every single line that I just skipped. Now we know that cos 2a is an eighth. Let's write that up there. Cos 2a equals an eighth. We could also potentially draw another triangle for this. Yeah, let's try that. Therefore, this side is going to be root 63. 64 minus 1. Okay, I don't know if that will come in handy, but why not, right? That means we can say sine 2a is going to be root 63 on 8. Maybe it'll come in handy, who knows. Now we'll have to deal with this cos 3a. It'll be half outside of an eighth minus cos 3a is cos 2a plus a. Let's use this one here. We're gonna have, this is gonna get long and confusing, but we'll have to be careful. Cos 2a, I'm just gonna put a bracket here, cos 2a times cos a minus sine 2a sine a. Yes, equals a half outside of an eighth minus, we have cos 2a is an eighth, cos a is 3/4, oops, minus sine 2a is root 63 on 8 times sine a is root 7 times over 4. Let's see if this gets us anywhere. I'm just going to make a bit more room. 3/32 minus, I'm just going to do the calculator for this part, 21 out of 32. That's nice. 21 out of 32. That's equal a half outside of an eighth. That will be plus 18 on 32, which is equal to 1 on 8 plus 18 on 32 times a half, 11 on 32. Let's see. There it is. C, 11 on 32. Whew, that was a long one. And many chances for error. So I see a lot of students making a lot of errors just anywhere along this working out because it's so long. There is another way of doing this apart from trying to deal with this root 63, because I do see that this is sine 2a, which you could turn into 2 sine a cos a. And if you turn that into 2 sine a cos a, you can still use the first triangle, because we've got the sine a and cos a, and you don't have to deal with the sine 2a of this triangle. So that's another way you could have done this. Instead of going to here, just swap that out as 2 sine a cos a, and then you can substitute in the values for sine a and cos a from here, and you should still get to 11 out of 32. Well, that is it. My brain is fried. Thank you for asking those questions though. I love the challenge. If anyone else need any help with anything, let me know in the comments and I might make a video for you. Until then, see you in the next video. Bye!